All right, so hopefully question two is not nearly as bad or long as the last one. It wasn't that bad. So a lot of ways you could attack this question. You could actually use rules of logs to rewrite this as 3 times the natural log of x and then take derivatives this way. I don't think a lot of people may realize that at first, so I'm going to do it the way that most people have done it. Right, so if we take the derivative, then we're using the chain rule here. So for natural logs, we take whatever's in the argument. Well, actually, before I do that, my bad. Let's find the domain. The domain, right? So logarithms always have to be positive. So this means x cubed has to be positive. X cubed is going to be positive whenever we're between 0 and infinity, just in case we get some issues. All right, so then when we create the derivative, right? So this x cubed just ends up chilling in the bottom, x cubed, and then the derivative of that. So the derivative of 3x is x cubed is 3x squared. We get some cancellations and we get 3 over x. Right, notice that's the same thing you would get if you just took the derivative of 3 times the natural log of x. So here's why understanding the domain helps, because it looks like we would have a critical value, not in the top, right? Because 3 can never equal 0, but it looks like we'd have a critical value when x is equal to 0. However, 0 is not in our domain, right? We can get close to 0, just can't actually equal 0. So that means there's no critical values. If we were to, this means it's not going to have a max or min, by the way. So then, second thing, if we take the second derivative, we're just taking the derivative of 3 over x, right? So I will leave that here. You can either bring the x to the negative 1 up and do derivatives or whatever. We're going to get negative 3 over x squared. And again, we can see that there's going to be a 0 in the denominator when x is 0, but we can't have x is equal to 0. So there's no possible inflection points. All right, so since the domain of this function is just 0 to infinity, we just care about the function from 0 to infinity. All right, so here's 0 that we can't equal. So if I look at, say, f prime, if I plug in any positive number, well, 3 over any positive number is going to be positive. So that means f of x is always going to be increasing. If I plug in any positive number for negative 3 over x squared is always going to be positive. Negative 3 is always going to be negative. Negative over a positive means that we're going to get a negative number. So this means f of x is always increasing and always concave down. All right, so we would look something like that. Like increasing, concave down. That one was much better.